Imagine you're driving down a highway at an average rate of 55 miles per hour. But think about this. Your speed is constantly changing, even in tiny ways. How can we measure something that's changing every instant? Or picture a river winding across the valley. If a river curves through the land and its width changes along the way, how do you calculate the area it covers exactly? These are the kinds of questions calculus was invented to answer. Calculus is the mathematics of change and accumulation. It helps us understand motion, growth, and how things add up over time or space. There are two main parts: differential calculus, which helps us understand how things change, like speed, slope, or population growth, and integral calculus, which helps us understand how things accumulate, like distance traveled, area, or total income over time. Let's look at the first big idea, the tangent line problem. Say we have a curved graph, maybe something like y equals x squared. We want to find the slope of the graph at a single point. But wait, slope is usually rise over run between 2 points, so how do we find a slope at just 1 point? Here's the key. We pick a second point nearby, draw a line between them, called a secant line, and then move the second point closer and closer. As the 2 points merge, the slope of the secant line becomes the slope of the curve. This process, getting infinitely close, is what we call a limit, and it's the foundation of derivatives. Now for the second big idea, the area problem. Let's say we want to find the exact area under a curve, like y equals x squared, between 2 points marked by the orange dotted lines. Since the curve isn't a simple shape like a rectangle or triangle, we can't just plug into a basic formula, but we can approximate it by breaking the area into several thin rectangles. The more rectangles we use, the better the approximation. By taking a limit as the number of rectangles approaches infinity, we turn an approximation into an exact area, and this is the idea behind integration. Calculus is used everywhere: in physics to describe how fast something is moving or how it accelerates, in biology to model the spread of disease or growth of cells, in economics to find the best way to maximize profit or minimize costs, and in many other ways. Calculus was developed in the late 1600s by Isaac Newton and Gottfried Wilhelm Leibniz, working independently. They introduced this new kind of mathematics to describe and analyze continuous change, such as falling objects, flowing fluids, or the motion of planets. So here's the big picture. Differential calculus, which deals with derivatives, helps us answer how fast is something changing. Integral calculus helps us ask how much has something accumulated. And limits are the foundational tool that makes both of these possible.